This is Honors Algebra 2 Pre-Calc. We are doing section 2.7 in the Pre-Calc book, which is actually part of the chapter 6/partial fractions unit. So example 8, write the partial fractions decomposition for this lovely rational function. So first thing to notice is the denominator is already factored for me, right? So this is a quadratic factor, but it repeats. Okay, so it's a quadratic factor that repeats, but it's already factored for me. So what this is going to look like is this is going to look like an x squared plus 3 on the bottom of the first fraction, and then this x squared plus 3 quantity squared on the bottom of the second fraction, right? And then on top of the first fraction, right, I'm going to have an ax plus b because it's a quadratic factor, so it needs a linear numerator. And on top of the second fraction, I'm going to have a cx plus d. Again, you don't have to use the same letters I use, but they do have to be 4 distinct values for those. All right, cool. So let's walk through this. So remember that the denominator I want is this x squared plus 3 quantity squared. What that means is that fundamentally this is an x squared plus 3 times another x squared plus 3. There should be 2 of them total in the denominator. That means that this cx plus d already has exactly the denominator it needs. It already has both of them. And it means that this ax plus b fraction is missing the other one, right? So I'm going to have to multiply that whole binomial on top. So what that means is that when I ignore the denominators, now that they're all the same, right? When I look at the numerator only because all of the denominators are the same x squared plus 3 quantity squared, I'm going to get a 2x squared plus 11 equals this quantity ax plus b times an x squared plus 3 plus a cx plus d, right? So there are a couple options here, but the first thing I want to point out is that it's going to be really hard to use clever substitution to find all of these. Here's why. There's nothing you can plug in to knock out d. D is just a d. There's no x next to it. There's no x minus 1 next to it. You can't plug anything in. And similarly, while you could knock out a and c pretty easily by plugging in x is 0, there's nothing you can plug in to knock out an x squared plus 3. It's not going to happen. The only thing, that's not true. You could plug in a plus or minus the square root of 3 times I, but that's awful, and you don't want to do it. It's a bad life choice. So since that's not really a choice, clever substitution is not a good choice here. No matter what you plug in, you're not going to instantly get an answer. So this is one of those times that I'm going to say it's worth foiling things out and then doing the other method. So if I FOIL this guy out, right, my first term is going to become an ax cubed, right? Outer is going to be a plus 3ax. Inner is going to be a plus bx squared. And then last is going to be a 3b, right, plus cx plus d. Well, an interesting thing actually happens, because what I want you to notice is that there's only one cubed term and there's only one squared term. So that's probably going to be enough to let me find a and b right away. Now, some of you might be thinking, but Hogan, the left-hand side doesn't even have a cubed term. That's an astute observation, and you are correct. So the left-hand side has to equal the right-hand side for every x ever. Well, the highest power I see anywhere is an x cubed, so it needs an equation that involves x cubes, and then I have some x squareds, and then I have some x's, and then I have some numbers, right? There's nothing higher than an x cubed on either side. So let's start with the x cubes. There are no x cubes on my left-hand side, and the only x cube on the right-hand side is ax cubed, right? So 0 has to be a. Well, that's nice, right? So that took care of my cubes, because there were no cubes on the other side. Well, my squared terms, there's only one squared term on this side. It's a 2x squared. And there's only one squared term on this side. It's a bx squared. Oh, look, b is 2. So as much as it was a pain and not something you were looking forward to FOIL all this out, right? It's a shame to have to do that. It turns out that in this problem, after you FOIL it out, you get 2 answers given right away, a and b, done. Right? Now we look at the x terms. Well, there are no x terms on the left-hand side. There's none. And on the right-hand side, there are 3ax and a cx. So 0 has to equal 3a plus c, right? Well, I already know a, so I can find c, right? That means that 0 equals 3 times 0 plus c. Oh, look, my c is also 0. So very quickly, I found a, b, and c. And then lastly, I have to find d. Well, 11 has to equal 3b plus d, right? 11 equals 3b plus d, but because I already have b, that's not a big deal. 11 has to be 3 times 2 plus d, So 5 must be my D. So even though it seemed like a lot of work on the front end to FOIL everything out, it was a much easier solution than clever substitution because a lot of things got knocked out. So then if I want to go back up, and I'm going to see if I can squeeze my final answer at the top because I'm a little bit low on space down at the bottom, it turns out that since both my A and my C are 0, I just don't have any x terms. So you could write it as a 0x, but I'm going to argue it's easier to just write 2 over the x squared plus 3 plus a 5 over the x squared plus 3 quantity squared, right? So it turns out, now, if you want to write the top as 0x plus 2 and 0x plus 5, that's fine. I think this is the easier option.